I mean, he's on pitch. Like, yeah, he's good. Okay. Am I recording? I think it is. I better turn the volume up just in case.
That's going to be in the big.
For our dear Nick, who is not here, so he can have his lessons. Actually, it's not just him. It's for a couple other students too. Okay. 10.2. Finding arc measures. Let's talk about that real quick. I'm going to minimize that. Arc measures. Why are there two screens? Hold on. I don't want to mess this up. I don't want to have to re-record it all over again. What does this mean?
It's just telling you it's recording.
Okay. Here we go. So, arc measure. Let's talk about what an arc is. This whole chapter is about circles. Okay? An arc is a piece of your circle. So does anybody remember what you call like the perimeter of a circle on the outside of a circle? Anybody remember that? Yeah? Circumference. So think of arc as like a, okay, you guys really got to reel it in and pay attention. Put your phones away, put your headphones away, put it all away. An arc is a piece of the circumference. Okay? Now, there's a difference between something called arc measure, which is what we're going to look at this year, and arc length, which is what I believe you don't get into until next year. Arc length would be like if I were to cut this piece of the circle out as a curve, straighten it out, and then measure it, like in inches or feet or centimeters or whatever. That would be an arc length. An arc measure is measured in degree measures, degrees. And that you have to think about is like how far it's rotated. So arc length is if I were to take it and straighten it out and measure it on a ruler, and arc measure is like how far it's rotating. Now, central angles. Let's talk about central angles really quick. Well, actually, I'll go back to that. It's like I'm missing something.
Are you still recording?
Yeah. So, central angle. A central angle, like if I were to cut a slice out of this circle, so like a piece out of a pie or a pizza slice or whatever, the angle that it makes in the center, right here, would be what's called a central angle. So, if your vertex is in the center. Okay, central angle is an angle whose vertex is the, center. Ooh, I forgot to say in the video that we are on page 285 in your journal. 285.
Here you go, Nick.
Okay, so a central angle is an angle whose vertex is the center. We haven't talked about the word vertex in a while. Vertex is like where the actual angle is at. It's where like the two sides of the angle are. Okay, and you're never going to hear me call it a circular arc. You're just going to hear me call it an arc. I think all arcs are part of a circle, but I could be wrong. But it's a portion of the circle, so like the little curved piece. And this is important. Your circular arcs or your arcs, this is not on your vocab list, right? And that's okay. Just understand that your arc is the same measure as your central angle. And you don't necessarily have to write that down if you remember it. So if we go back to our picture for a second, if this angle was 60 degrees, okay, then the arc that it intersects right here would also be 60 degrees. That's how much it's rotating from the first point to the second point. If you had another one and this angle was 140 degrees, then from this point all the way to this point on the arc would also be 140 degrees. So your arc measure is the same measure as whatever your central angle is, okay? Now let's talk about a couple of really important things today that you'll want to know. If you don't know these, you're going to want to write it down. Full circles. I can't really draw a circle well. I'm just making it worse. Okay. Full circles. Do we know how many degrees are in a full circle by raising your hand, not learning out loud? Jordan? 360. A full rotation is 360 degrees. Right, skateboarder Haley? Half of a circle. Okay, so and remember, diameters, we talked about diameters in 10.1. Diameters always cut a circle in half. There's infinitely many diameters, and all of them cut circles in half. What would, who can raise their hand, half of a circle be in degrees? Haley? 180. So when Haley's on her skateboard and she's like, and that's a 180, right?
I don't know if you do that.
That's exactly what you look like. No? 180, and she got that from half of 360. Now that should make sense because your arc is the same measure as the central angle. Half of a circle, your central angle is your diameter, which is a straight line. And we've known for a long time that a straight line is 180 degrees. So that measure still comes from the fact that your central angle is the same measure. You're going to want to keep these two things in mind today because we're going to do a little addition and subtraction stuff. So know that a full circle is 360 and half a circle is 180. Okay, then we're going to talk about minor and major arcs. In your own words, what would you say is the difference between minor and major? Just kind of in your own words. Who wants to raise their hand and give me something to work with? Minor and major. What's kind of the big difference? Big and small, that's exactly right. Like if I'm playing baseball, I'd probably rather play in the major leagues than in the minor leagues, right? Do any baseball players in here? You play baseball? Right, like you'd want to be a major league player, maybe, other than a minor league.
I used to play baseball.
So a minor arc is going to be a small arc in the circle. Minor arc is going to be an arc that's less than half the circle. So in other words, the measure will be less than 180 degrees. So we're back in the journal. A minor arc would be an arc that's less than 180 degrees. And typically, not always, I want to promise you, but typically your minor arcs are written with 2 letters, and we'll get into why that is in just a second. So if your minor arcs are less than 180 degrees, what do you think your major arcs are? More than 180 degrees. 360, yeah, exactly right, would just be a circle.
So it was 359.
Right. And major arcs are noted with 3 letters, and here's why. I'm going to draw this on the smartboard so that my video can see. If I have a circle, and I have a point here called A and a point here called B, and I said, find the measure. Let's see, I'm going to make this 100 degrees, and I said, find the measure of arc AB. You'd probably ask yourself, well, are you talking about this AB, or are you talking about this AB? Because they're both AB, right? They just go in different directions. That's why we make major arcs with 3 letters, so that we know if there's a third point here called C, I would call that arc ACB, and then the little arc AB. So typically minor arcs, the ones that are less than 180, are with 2 letters, so that we can differentiate between the major arcs going the other direction, which typically have 3 letters. And you'll kind of see that in effect in a second. Now, if I knew this was 100 degrees, that means this arc is 100 degrees. Does anybody have an idea if I wanted to know the rest of the circle, like arc ACB, how I could find that arc? Adrian? 360 minus 100. A full circle is 360. The minor arc was 100, so the major arc would be whatever the difference is. So I added that in there. If you want to put that in there, you don't necessarily have to, as long as you understand that a full circle is 360. But if you're given a minor arc, then your major arc would always be whatever the full circle is minus the minor arc. One definition that's not up here that we should add on our list is semicircle. Okay? Minor arc is less than 180 degrees. Major arc is more than 180 degrees. What do you suppose? I'm missing a lot of calculators. Do you have any calculators out right now?
I do.
Okay. Anybody else have one? Okay. What do you suppose a semicircle is, Sam?
Half a circle.
Half a circle, which would be what? Exactly 180 degrees. But Sam is right, that would be half of a circle. Semi. Right. And then when we get into spheres, 3-dimensional circles, next section, those aren't called like semispheres, they're called hemispheres, but okay. does that mean?
I mean, like, you're doing this.
Like drawing? Both for me, but
No,
How do you even draw
not
this, dude?
drawing. Like,
Oh.
you
you go like this, and then you draw the little like radius on the inside, and then that makes it like a. It's hard. Sorry, say it again. Okay. Wait till next chapter, then you can tell me which one's harder. All right, so this is an overview of what I just said. So we've talked about central angles that come from the center, because eventually we're going to talk about something called an inscribed angle, which is different. The central angle has to be the same measure as the arc that it intersects, and then we have a major arc and a minor arc. So you can see here, when you name arcs, your minor arc has the 2 letters, your major arc, the order of your letters matters, because arc ADB and arc ABD are two, guys pay attention, are 2 different arcs. So word to the wise, you could think about it as like 2 different arcs connected, AD and DB, if you want to think about it that way. Or think about, I just have to start at A, go in the direction of D, I have to cut through D first, and then I have to end at B, and that'll kind of keep your mind in check. But some people just think about it as 2 different arcs, and then trace them all together. That helps at all. Talk about that. Okay, so first example here before lunch says find the measure of each arc of circle P where RT is a diameter. You have a problem though. Your 3rd letter is the same as your 2nd letter. So can you change letter C to arc RST instead of arc RTS again? I don't actually want you to find the same arc twice. So on letter C, change it to arc RST. Because yours currently says the same thing twice. Okay? All right, letter A. Don't blurt any answers out loud, please. Arc RS, that'd be a minor arc here from R to S. Who can raise their hand and tell me how many degrees that arc would be, besides Sam? I've heard from Sam a lot today. Thank you, though. Brooke? 110. It's exactly equal to the central angle that intersects it. And I know the directions don't ask this, and I already gave this answer away, but they will ask this on your homework tonight. Is that a minor arc or major arc or semicircle? That'd be a minor arc because it's less than half a circle. It's less than 180. I know the directions don't ask for that, but let's just practice it now anyway. RTS. So again, R to T comes first, and then T to S has to end at S. Who can raise their hand and tell me how big RTS would be? Scott? Where'd that come from? No, you're the only one to do it that way today. Okay, so he said 180 because this is half the circle, because we know RT is a diameter. That's an important fact. Diameters cut circles in half, so this is 180, and then he said he added 70 because he took 180 minus 110, and 180 plus 70 is 250. There was probably another way of doing that one, like another way of thinking about it. You could have done 360 minus 110, and that would have also given you 250. And then what kind of arc is that? Major or minor or semicircle? Major arc. Hold up. RST, that's a different arc. R to S to T. Who can raise their hand? Adrian? 180. Half of a circle. And then Adrian, major arc, minor arc, or semicircle? Semicircle. Easy norm. Someone sees Twy Miller, tell him to get his butt to class after lunch.
Oh, I think he's sick today.
No, he's not. He was here third hour.
Oh, he was. Oh. Oh yeah, I forgot.
No, he didn't.
He left.
He was ordering like a pizza. Like,
Just no Snapchat it and ask him where he was.
He said he's probably in the bathroom eating pizza.
That's easy. I know.
I haven't done 11 and 12 yet.
I don't need a story.
Starting up. All right, back at it. Adjacent arcs. Let's talk about this really quick. The word adjacent we've heard multiple times this year. Adjacent means like next to, connected. So like last chapter, the adjacent side was the one that was touching the angle. So adjacent kind of means touching, connected. So if we were looking at a circle, two adjacent arcs, if here was one arc, an arc adjacent might be something like this. So the definition is that it's arcs that intersect at exactly one point, but it's just arcs that are touching and connected. Okay, so we're gonna do a little throwback here. I don't know if I'll be able to handle it. It was a long time ago, way back in chapter 1. All right, if this is 10 and the piece adjacent to it is 3,
Oh, no.
I haven't asked the question yet. How much is this piece right here? 13. 10 plus 3. If I walk 10 feet and then 3 more feet, I've walked 13 feet total. If I have an angle, and I know that this is 20 degrees and this is 60 degrees, how big is the entire angle? 80 degrees. Okay. So this was called the segment addition postulate, and this was called the angle addition postulate. So the arc addition postulate, let's just say this was 50 degrees and this was 60 degrees, and then I asked you to find the entire arc. Pay attention. If this is 50 degrees and this is 60 degrees, and I said find the entire arc, just like segment addition and angle addition, arc addition, you would just add them together. So what's 50 plus 60?
110.
110. Okay? So looking at these examples here, arc GE, do not blurt out loud. GE, since it only has 2 letters, I know that it has to be the little arc instead of the big arc. G to E, who can raise their hand and tell me how big that arc would be? Avery? What? 120, because 80 plus 40 is 120 degrees. And then Avery, would that be a minor arc or a major arc or a semicircle? Minor. It's less than 180 degrees. Good. The next one, GEF. G all the way to E, ending at F. GEF, who can raise their hand and tell me how many degrees GEF would be? By raising your hand. GEF. Adrian? 230. 40 plus 80 we know is 120. Plus 110 would be 230 degrees. Very good. Add all 3 arcs together. And I know they only give you central angles, but we know that if the central angle is 40, 80, and 110, all the arcs are 40, 80, and 110. And then Adrian, major or minor arc? And then the last one here, GF, arc GF. Ooh. Who can raise their hand and tell me how big GF would be, Darian?
130.
How'd you get 130?
360 minus 230.
Very good. 360 minus 230. All of the blue we just calculated was 230, so 360 minus 230 would be 130. Good. And then Darian, major or minor arc?
Minor.
So again, this is an example of showing you, I know HF kind of looks like it's a straight line. Make sure if they give you measures that you add them together. That would be 190 instead of 180. So HF is not a diameter. It's not a straight line. They should tell you whether or not it's a diameter, but they don't always do. They don't always tell you. So if you see a straight line, it probably is, but just be careful with that. Questions on that? We're going to skip that one for right now. Okay. Congruent circles and congruent arcs. Let's talk about congruent really quick. You don't ignore this slide. What does congruent mean in general? What does congruent mean that we've said since the beginning of the year? Tiffany? The same size. So if I talk about congruent circles, circles that are the same size, how would you tell if two circles are the same size? Well, every circle is 360 degrees, so it has nothing to do with degree measure, because you could have a circle this big and you could have a circle this big that are both 360 degrees. Question? True, and I'm just going to simplify or shorten that a little bit. You tell by the radius. Circles are congruent if they have the same radius or same diameter. She's right. Okay? Two circles that have the same radius. This will 100% be a fill-in-the-blank question on your quiz. It's going to say congruent circles have the same blank. Congruent circles have the same radius, but if you were to put diameter, that would not be incorrect. That would be true as well. The radius of the circle is kind of like the foundation, like when you talk about area, pi r squared, or you talk about circumference, 2 pi r. You're talking about it in relation to how big its radius is. And then congruent arcs have two things that they have to meet, two kind of requirements here. Congruent arcs are two arcs that have the same measure, so they have to be like both 100 degrees or both 20 degrees. And then they either need to be on the same circle, like this, or on congruent circles. So in just a second, I will show you a counter example of two arcs that would not be congruent. So congruent circles have the same radius, and then congruent arcs have to have the same measure, degree-wise, and then they either need to be on the same circle, like this picture, or be on congruent circles. So let me show you an example of two arcs. Yes? Sure. Let me show an example of two arcs that are not congruent to each other. Thank you. Just see me teaching year one. Not so pretty. All right. If I asked you to find the measure of this arc right here, what would you tell me? Measure degree-wise. What would you tell me? 90 degrees. Because the central angle is 90 degrees. A quarter of a circle. If I asked you to tell me the measure of this green arc, what would you tell me? Huh? 90 degrees, because the central angle is 90. Are the red arc and the green arc the same size?
No. Yes. Maybe. Yes.
No.
Are the red arc and the green arc the same size?
Yes.
When you look at the red arc and green arc, you're telling me they are 100% the same size.
No.
No? Why not? Which one's smaller? The green arc is smaller. Correct. Okay. And it's because they have the same measure, but they're not on congruent circles. These two circles are not the same size. So they do have the same measure as each other, but they're not the same size because they're not on two circles that are the same size. So this would be an example of arcs that have the same measure, but they're not congruent to each other. So here real quick, and I didn't even mean to print in color on the green pieces of paper, but it worked out real nicely for me because now you can see the red arcs. I know, right? It worked out so nicely. Tell whether the red arcs are congruent, explain why or why not. So two things have to be true. They have to be the same measure, and then they either need to be on the same circle, like that, or they need to be on congruent circles. Do those two red arcs have the same measure, degree-wise, yes or no? Yeah, they're both 80 degrees. And since they're on the same circle, yes, those two arcs would be congruent to each other. They are both 80 degrees and on the same circle. I didn't mean to put a period after and. Sorry. Okay. Letter B. Letter B, you have two different circles. You have this little circle on the inside and then the big circle on the outside. So it's kind of like the last picture that I just drew for you, but you took the smaller circle and put it inside the bigger one. So this arc is 90 degrees. This arc is also 90 degrees. But are those arcs congruent?
No,
No. And why not?
because they're not in the same circle.
Because they don't have to be on the same circle.
Oh, because one's bigger than the
Because they have to be on congruent circles. So we can say, no, they're both 90 degrees. I would be okay with you saying because the one's bigger than the other. Or they're not on congruent circles. That's literally why. They are the same measure. They're both 90 degrees, but they're not congruent because they're not on the same size circle. Letter C, are those two arcs the same measure of degrees?
Yes.
Okay, yep, they're both 95 degrees. Are those two circles congruent to each other? Do they have the same radius?
Yes.
Yeah. And we know because this line and this line are the radii and they have a tick mark telling me that they're congruent to each other. So this one is another yes because they are both 95 degrees and on congruent circles. The radius is the same in both those circles. Me too. Okay. Two more. One more definition, and then we'll start our homework together. Number 7. Are they the same degree measure? Yes or no? Yep. Are those two circles congruent? Yes or no? Yep. So the arcs are congruent because, again, just like the last one, they're both 145 degrees and on congruent circles. And then the last one, I'm going to open that one up to you guys. Yes or no, do we think those are congruent arcs?
No.
Andrew, why not?
I don't know. Oh, because there's a 4 and a 5.
That's exactly right. The 4 and the 5, the radii, the two radiuses, they don't match. They're not congruent, which means the circles are different sizes. So 4 doesn't equal 5, not congruent circles, not the same radius, different sized circles, however you want to phrase it in your own words is fine. Okay, hold on one second. One more definition to write down. And then we'll start our homework together. Similar arcs. So if you remember back to triangles, we talked about congruent triangles that were exactly the same. And then we talked about similar triangles. Similar triangles looked the same, but one was bigger than the other. So that's kind of like those arcs right there. So similar arcs typically have the same measure, but they're not part of congruent circles. So they're different sizes. They have the same measure, but they're different lengths because they're not on congruent circles. There's your last definition. And that theorem at the top says all circles are similar. And that should make sense because all circles are the exact same shape. They're just different sizes. So every circle would be similar to another circle. And then once that's written down, get your 10.2 worksheet out because I made another mistake.
It's okay. Everybody makes mistakes. Everybody has mistakes.
And because I made a mistake, we're going to number 11 together, so that we're on the same page.
Yay!
So 11 and 12 say, tell whether the red arcs are congruent, explain why or why not, and that does not make any sense for those two problems. I just must have left off those problems on this worksheet for the well. So we're not going to do any problems like the ones we just did on the homework, but they will be on your quiz review because they'll be on your quiz, just so you know. So 11 and 12, that's what the directions should say if you want to go ahead and write that down. Solve for x and then plug in x to find the red arc. Red arc, Miss Kelly, it's copied in black and white. Yes, I know. So on 11, the red arc is arc BC, and on number 12, the red arc is arc RST. So you might want to either color it or mark it on your paper since you can't see red when I make copies in black and white. Goodness. Now, I will say 1 and 2, when it talks about the red minor arc and the blue major arc, that should be easier for you to identify because the red arc is the smaller one from A to B, and then the major arc is the big one from A to B. So you really don't need colors there. Okay, let's look at number 11 together. How are we going to set up an equation to solve for x? We just solve for x, and then we'll plug it in to find arc RS. Who has a thought here? AB is a diameter, that'll be important. Kylie.
2x minus 3 plus x.
Awesome. 180, because AB, that straight line down the middle, cuts the circle in half. So Kylie's exactly right. The 2x minus 30 and the x put together makes up half the circle. So it has to add up and equal 180. So then let's do some algebra. 2x plus x is 3x. Remember, when they're on the same side of the equal sign, you just add like terms. Add your 30 over, and we get 3x equals 210. Divide by 3, and we get 70. Okay, that's x, so that takes care of the first part. I'm going to pause for a second. If I'm going too fast, you guys speak up and let me know. Again, it should make sense that they have to equal 180 because it has to make up half the circle. Okay, now we got to plug it in for the red arc. The red arc is arc BC. So what would we do from here to find arc BC? Brooke?
70 and the x is 2. 70 minus 30.
So we're going to use the 2x minus 30 since that's marking BC. 2 times 70 is 140 minus 30 is 110 degrees as your final answer. And then I'm not going to do RST with you, but I'm going to give you a hint. How about that? Number 12, they mark, there's no diameters there, so you can't do anything with 180 because you don't have any half circles. But you do have every single little kind of portion of that circle marked. What does a full circle have to add up to? 360. So you should be able to add all 4 expressions around the circle and then set it equal to 360 and solve.
It's not funny.
Just 10.2?
Don't miss
That one.
We're having severely confused. We're having severely confused. Yeah.
Doesn't that like 6 minutes of hot sauce?
Okay.
When we find the plug in,
That's what I said. Yeah, do you want to get yours?
Okay, guys, have a seat. A lot of people today have finished up this worksheet or gotten really, really far on it, so I'd like that to be the same thing in here. Don't put it away.
You got the answer all of them. Honestly, you need to know it for